Yes, I know it's not technically needed to be a good software engineer, but what if I told you we need DSA to be a good software engineer? Stick with me. These hard DSA questions have most developers spending countless nights on lead code, hacker rank, and whatnot, wondering if they'll be able to invert that binary tree in their day jobs and if they will be able to make the actual cut in the interview. But what if I told you that the point of doing these frustratingly hard DSA questions isn't just to clear these interviews, it is much more than that. In this video, I'm going to show you how mastering DSA, or data structures and algorithms, isn't just about interviews. It is about rewiring your brain to think like a computer and write better code, and hence solve better problems, which sort of gives you an edge in the tech industry. I will reveal how understanding these fundamentals can transform you from a simple code writer to a proper software engineer, a person who solves actual problems irrespective of syntax and framework and library and whatnot. Stick around, this might just change your view on programming forever. Hey guys, I'm Anudeep and I work as a software engineer, and I have had sort of a love and hate relationship with DSA for the most part of my life until recently when I realized its importance. Back when I interned at MathWorks, I did a bunch of DSA to get the internship, and even when I was searching for full-time jobs, I did grind out lead code, I won't lie, and it was not the most pleasant of experiences. But if I knew what I'm gonna tell you today, maybe that whole experience might have been a bit smoother. Let's talk about why DSA is more important than you think. So, computers work on data, and data structures are essentially structures for how to organize this data. And algorithms, on the other hand, is how this data interacts with one another and modifies and produces the output that we want it to produce. And to be honest, at first glance, this DSA looks like just another hurdle to, achieving your dream job, getting that big tech offer. But let's take a closer look why these big tech companies and why this so-called broken tech interviewing system is based on data structures and algorithms. So the general trend is that you should do DSA if you want to get into big tech. And these are not just regular applications where you are being interviewed on a library or a framework, or you're doing a startup, or you're doing freelancing. These are actual big tech companies where they're going to pay you millions of dollars throughout the years that you work for them. So basically these are very competitive roles, and that's why these companies are looking for an objective metric, a way to gauge whether you have the core thinking skills needed for the job. Now, why do these companies use specifically DSA as the filter? Imagine a recruiter faced with thousands of applications. It is very difficult for them to be able to go through every project of yours, because every project is written in different language and different framework, and each has its own applications. And on top of that, resumes can be padded. You can absolutely go bonkers and write whatever the hell you want to write in your resumes. So these companies sort of need an objective first pass, which is not a resume, something that is objective and something that can only be passed by somebody who has foundational knowledge of problem solving. And you might ask, why DSA is the only objective metric? Well, because data structures and algorithms sort of assess your core computer science thinking skills. They reveal how you think about memory usage, space usage, runtime efficiency, all while doing logical problem solving, meaning solving a particular problem, but within these constraints. And these are sort of skills that don't just make you a coder who just gets things working, they make you an engineer who builds robust, scalable systems. And that's exactly what these companies are looking for. They don't just have tens and hundreds of users. Their users span millions, if not billions of people around the globe. And for that, they need people who can firstly solve problem, and secondly, solve them within constraints, solve them in a way which requires less resources, less space, less memory. Because even if you're not in tech, even if you are not a technical person, if a page that you are loading, or if an app that you are opening, if that takes even half a second more, you would not want to use that app. And all these software engineers are working on exactly this sort of thing. So while it might feel like a useless grind, but mastering DSA is a proof to yourself, and most importantly, and also to your employer, that you've got the deep thinking skills needed to handle complex and high pressure tasks. We all live in a time when AI assistants can absolutely spit out virtually any piece of code that you ask it to. Need a sorted linked list. If you need to sort a linked list, or if you invert a binary tree, boom. Almost all of these LLMs can just spit out that code snippet that does that. And sure, it makes us feel powerful. And I was just going through a bunch of articles where, people have made these new tools. One of those interview helpers, which are apparently banned, but apparently everybody uses at interviews to, pass these interviews. But then if you just pause and think that if you're using one of these tools, do we really understand the code? And you might say that, well, I don't need to understand the code. I just need to pass the interview, because definitely I won't be, solving that complex problem at my day job. And that is true. But to be able to solve that complex problem means that you will excel at your job. Like, it is one of those things that helps you become a better software engineer and helps you gain reputation in your career. So if you skip on that now, it's sort of going to haunt you for the rest of your life until you fix that. Because if you're changing companies, or if you're changing roles within the same company, if you're getting promoted and if you want to give an interview for that, and they might ask lead code questions and these DSA questions, and if you have not mastered it at this earlier stage, all of these things will continue to haunt you later because you took help from an AI tool and stuff. And surely the interview process might evolve in the future with these AI tools giving perfect answers. But one of the things that you need to understand is that if the interviewer is smart, they might change the edge cases or the conditions, and they might ask you to modify the code on the spot. And if you haven't coded it up yourself, if you have not thought through the problem yourself, you might not be able to make the cut. But most importantly, the point that I'm trying to make is true mastery comes from owning the solution. It comes from understanding why each line of code exists, why you chose that particular condition, why you chose those particular constraints, what are the trade-offs, and how to adjust it when things go sideways. Imagine you are at work and something happens at production level. But even as junior, you might be put in those pressure situations, and you can't always be searching Stack Overflow, or these days just prompting ChatGPT to get the answer. You have to understand what is happening beneath the hood. You have to go through the reps of a particular problem solving pattern multiple times to be able to form that mental model, that way of thinking, which enables you to solve a problem fast in pressure situations correctly within time. And yes, AI can help you out with that, but the problem arises when AI takes the driver's seat. AI is just a tool, and I agree, it's an incredible tool. But without foundational knowledge of DSA, you're just copying and pasting, and that sort of is not what an engineer does. We can hire clerks for that. But with DSA knowledge, you're thinking, you're adopting, and you're problem solving the way an engineer is supposed to work. And that is where you will get the big bucks. That is where you'll get your dream offers, because now you're acting like a knowledge worker, a person who thinks and responds and adjusts and forms solutions to problems. So, if you have come to this point of the video, all that I have said is sort of on the internet somewhere, but the point that I'm trying to make in this video is that mastering DSA opens up a whole new world of possibilities for you. Even if you don't want to go into big tech, even if you don't want to be a competitive coder, hustling through DSA, like grinding 3 to 4 months of DSA and doing these lead code problems, is one of the best things that you can do in your career. Because if you know DSA, suddenly you're not just limited to roles that emphasize frameworks or libraries. You can apply to mid-sized companies, big tech companies, or these research labs and stuff. You can apply to virtually every role without the fear of having to prepare for DSA and not knowing how to solve these problems, because your tech stack, you have built projects, but you are not able to get into these companies because you didn't put in these 3 to 4 to 5 months of hard work practicing and mastering DSA algorithms. Trust me, this foundational problem solving knowledge is universal. And on a deeper level, even more than career options, DSA changes you as a person. It sort of transforms your brain in a weird way. I call it workout for the mind, or in some other analogy, a fertilizer for the mind. Every problem you solve lays down new neural pathways, new ways of thinking, and new ways of problem solving, making complex concepts click faster the next time you do it. And once you have gone through the grind, taken notes, made your own cheat sheets, you can revisit every problem or every similar problem in minutes by revising your notes, refresh your memory, and confidently tackle the next interview or the next project that you're going to build to write clean and better and more optimized code. You can do all that in just a moment's notice. Changing companies, switching industries, switching careers for that matter, or even exploring new tech domains. All of this becomes as easy as just revising 10 to 20 pages of your notes instead of relearning everything from scratch. So I'm gonna go over some misconceptions floating on the topic. Number 1, DSA is only for FAANG. Now, it's a common belief that you want to do DSA and lead code style questions if you want to, apply for these big tech companies like Google, Amazon, Meta, whatever. But if you don't aim to go to these companies, you just don't need to bother with it. But that is just not true. Every serious tech team, be it at a startup or at a big tech company, mid-sized company, they would require you to have some basic understanding of DSA. And because this is not your small little project that you're building something for a large number of users, and as the number of users increase, as your application scale, how optimized and clean code you write becomes more and more important, as opposed to just making the functionality work when you're just building your first front-end project. And that's why DSA isn't just about cracking interviews, it's about giving yourself that launchpad to build software when it matters the most. Point number 2, yep, DSA can be hard. It is definitely irritating when you're not able to solve the problems initially, but from my personal experience, I felt that breaking the whole subject down into smaller and smaller topics and then tackling one topic at a time is a very useful strategy. Don't try to do everything at once, as I said. It will burn you out, and believe me, I have been burnt out a couple of times doing DSA. Instead, focus on one data structure for 1 week, spend a few days understanding it, the next few days experimenting with it, and the next few days solving 3 to 5 different problems, and then the next few days solving some new problems. Keep on solving until you get comfortable and the patterns that you're solving feel intuitive. Review what you learned on before moving on, and then you move on to the next one. Trust me, this kind of slow, steady pace compounds over time. You'll be amazed, as I was, at how concepts that once did not make sense are coming very naturally to you. And lastly, honestly, use what you know. If you're comfortable with Python, do that. It is one of the most popular languages for doing lead code and DSA because it has less complex syntax and you can not worry about memory declarations and variable declarations and whatnot. And that's good. If you purely want to focus on problem solving, do that. I come from a robotics background, so I use C++ because it helps me, give more control over memory and all those things. But again, that's not necessary. People get way too hung up on, which language should I use and, what should I start with? See, all of these things are your brain procrastinating. All of these things are your brain telling you that what is in front of me, I don't want to do that because it's tough and I can't solve a particular question, and I'm going to make these excuses. But if you are wise, which you are, you're going to not listen to your brain and just start with whatever language you think is necessary. I've seen people do DSA in Java because, they want to work on backend systems and it helps there as well. So it doesn't matter. And even if you want to, work in some other industry and, you are doing DSA in a completely different language, it doesn't matter. You can pick that language up later. There is just no excuse. Focus on learning the core ideas first and pick the language that helps you do it the fastest. So here is your challenge. Block at least 1 hour every day for the next few months to practice DSA, to go through the grind and take notes, build your cheat sheet, and crush those problems until they feel intuitive. If you commit, and I can be sure of that, in a few months, you will walk into interviews or your new project with so much confidence and so less anxiety. I guarantee that it will be one of the highest ROI things you can do for your career, and especially if you are in tech. If you guys are ready to level up your problem solving and future-proof your career, I come up with these videos every week or every other week. If you like this video, please hit like and subscribe. As always, it means a lot, and I will see you guys in the next one. Happy coding!